As current flows through wires, it encounters resistance, which causes a voltage drop. Over long distances, this voltage drop can become significant, especially with higher current draw. In a shared neutral system, multiple circuits use the same neutral wire to return current to the electrical panel. This can compound the voltage drop if the circuits are carrying significant loads. Even if you increase the wire size, it may not be sufficient to compensate for the long-run distance and current demand. Loose connections, worn wires, or poor grounding can create high impedance in the circuit, further increasing voltage drop. Nonlinear loads, such as fluorescent and light-emitting diode lighting, can generate harmonic currents that interfere with the power supply and cause voltage fluctuations. Fluorescent ballasts and capacitors in light-emitting diode lighting can draw high inrush currents when energized. This can create voltage dips that prevent other lights from firing. Here are some troubleshooting steps to consider. Firstly, use a voltmeter to measure the voltage at the lighting fixtures and at the start of the circuit. Compare the values to the nominal voltage. Secondly, inspect the wiring for any loose connections, damaged insulation, or high resistance points. Thirdly, temporarily disconnect some of the lights to see if the remaining lights operate normally. This will help determine if the circuit is overloaded. Fourthly, if possible, separate the lighting circuits into smaller branches with dedicated neutrals. Fifthly, a voltage regulator can compensate for voltage drops by boosting the voltage to the specified level. Ensure that the ballast types used are compatible with the voltage conditions. Use capacitors or inductors to reduce harmonic currents and voltage fluctuations. Avoid overloading circuits or using excessively long wire runs. To expand on these points, let's delve deeper into the factors contributing to voltage drop. The longer the wire, the greater the resistance, and consequently, the more significant the voltage drop. Wire gauge is also crucial. A smaller gauge wire has higher resistance than a larger gauge wire. Therefore, for long runs, it's essential to use a thicker wire to minimize voltage drop. The amount of current flowing through the wire directly impacts voltage drop. Higher current leads to greater voltage drop. This is particularly relevant when dealing with lighting circuits, as the total current draw can vary significantly depending on the number and type of lights. Shared neutral circuits can exacerbate voltage drop issues. In a multi-wire branch circuit, the neutral wire carries the unbalanced current from the hot wires. If the loads on the different hot wires are not balanced, the neutral wire can carry a substantial amount of current, contributing to voltage drop. High impedance in the circuit can significantly increase voltage drop. Impedance is the total opposition to current flow in an alternating current circuit, and it includes both resistance and reactance. Loose connections, corroded terminals, and damaged wires all contribute to increased impedance. Harmonic currents, generated by nonlinear loads, can also cause voltage fluctuations and contribute to voltage drop. These currents are multiples of the fundamental frequency and can distort the voltage waveform, leading to various problems, including increased heating and equipment malfunction. Capacitive loads, such as those found in fluorescent and light-emitting diode lighting, can draw high inrush currents when initially energized. This sudden surge of current can cause a temporary voltage dip, which may prevent other lights from firing up. Let's break down the troubleshooting steps in more detail. Measuring voltage is a fundamental step in diagnosing voltage drop issues. Use a voltmeter to measure the voltage at various points in the circuit, including the source, the middle, and the end of the run. Compare these measurements to the nominal voltage to identify the extent of the voltage drop. Inspecting the wiring is crucial for identifying any potential problems. Look for loose connections, damaged insulation, and signs of corrosion. Use a multimeter to check for continuity and resistance in the wires. Reducing the load can help determine if the circuit is overloaded. Temporarily disconnect some of the lights and see if the remaining lights operate normally. If the voltage improves significantly, it indicates that the circuit is likely overloaded. Isolating the circuits by separating the lighting circuits into smaller branches with dedicated neutrals can reduce the current flowing through each neutral wire, minimizing voltage drop. This can be achieved by rewiring the circuits or installing additional wiring. Installing a voltage regulator can provide a stable voltage supply to the lighting circuit, compensating for voltage drops. Voltage regulators are available in various sizes and configurations to suit different applications. In addition to these troubleshooting steps, there are several other factors to consider. Ensure that the ballast types used are compatible with the voltage conditions. Some ballasts are designed to operate within a specific voltage range, and using the wrong type of ballast can lead to performance issues and premature failure. Capacitors or inductors can be used to reduce harmonic currents and voltage fluctuations. These components filter out the harmonic currents, improving the power quality and reducing voltage drop. Avoid overloading circuits or using excessively long wire runs. Adhering to electrical codes and best practices can help prevent voltage drop issues and ensure the safe and reliable operation of the lighting circuits. When dealing with long lighting circuits, it's also beneficial to consider the use of voltage drop calculators. These tools help you estimate the voltage drop based on factors like wire size, current, and distance. They can be invaluable in determining the appropriate wire size and circuit configuration to minimize voltage drop. Another important aspect is proper grounding. A good grounding system provides a low impedance path for fault currents, which helps to prevent voltage fluctuations and ensure the safety of the electrical system. Check the grounding connections to ensure they are secure and free of corrosion. Furthermore, consider the ambient temperature in the environment where the lighting circuits are installed. Higher temperatures can increase the resistance of the wires, leading to increased voltage drop. If the ambient temperature is high, it may be necessary to use a larger wire size to compensate. In some cases, it may be necessary to consult with a qualified electrician to diagnose and resolve voltage drop issues. An electrician can perform a thorough inspection of the electrical system and recommend appropriate solutions. Remember to always prioritize safety when working with electrical circuits. Turn off the power before performing any work and use appropriate safety equipment such as insulated gloves and safety glasses. Understanding the principles of voltage drop and neutral sharing is essential for designing and maintaining efficient and reliable lighting circuits. By following these troubleshooting steps and considering the additional factors discussed, you can effectively address voltage drop issues and ensure the optimal performance of your lighting system. The impact of voltage drop extends beyond just the lighting circuits. It can also affect other electrical equipment connected to the same power supply, leading to reduced performance and potential damage. Therefore, addressing voltage drop issues is crucial for maintaining the overall health and efficiency of the electrical system. One more thing to consider is the type of wiring used. Different types of wiring have different resistance values, which can affect voltage drop. For example, copper wiring has lower resistance than aluminum wiring, making it a better choice for long runs. However, copper wiring is also more expensive than aluminum wiring, so it's important to weigh the cost and performance factors when selecting wiring. Also, consider using dedicated circuits for sensitive equipment. This can help isolate the equipment from voltage fluctuations caused by other loads in the electrical system. This is especially important for electronic equipment that is sensitive to voltage variations. In addition to the troubleshooting steps already mentioned, it's also helpful to monitor the voltage over time. This can help identify intermittent voltage drop issues that may not be apparent during a single measurement. Use a data logger or recording voltmeter to track the voltage fluctuations over a period of time. This data can be valuable in diagnosing the cause of the voltage drop. Also, consider using power conditioning equipment to improve the power quality. Power conditioners can filter out noise, suppress voltage surges, and regulate voltage fluctuations, providing a cleaner and more stable power supply for the lighting circuits. Power conditioning equipment can be particularly beneficial in areas with poor power quality or where there are many nonlinear loads in the electrical system. Another factor to consider is the age of the electrical system. Older electrical systems may have deteriorated wiring and connections, which can contribute to voltage drop. If the electrical system is old, it may be necessary to upgrade the wiring and connections to improve its performance and reliability. Additionally, consider the impact of future expansion. If you plan to add more lights or other electrical equipment to the circuit in the future, it's important to factor this into the wire size calculations. It's always better to err on the side of caution and use a larger wire size than is strictly necessary to accommodate future growth. Proper documentation is essential for maintaining the electrical system. Keep accurate records of the wiring diagrams, circuit configurations, and voltage measurements. This documentation can be invaluable for troubleshooting future problems and ensuring the safe and reliable operation of the electrical system. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you're not comfortable performing the work yourself. An electrician has the knowledge and experience to safely and effectively diagnose and resolve electrical problems. By carefully considering all of these factors, you can effectively address voltage drop issues in long lighting circuits and ensure the optimal performance of your electrical system. And it's important to stay up to date on the latest electrical codes and standards. These codes and standards provide guidance on safe and effective electrical practices. Adhering to these codes and standards can help prevent electrical problems and ensure the safety of the electrical system. Consider using energy-efficient lighting technologies. Light-emitting diode lighting is much more energy efficient than traditional lighting technologies, such as incandescent and fluorescent lighting. Using light-emitting diode lighting can reduce the current draw on the lighting circuits, which can help to minimize voltage drop. Furthermore, consider using lighting control systems. Lighting control systems can automatically adjust the light levels based on occupancy and daylight availability. This can reduce the energy consumption of the lighting system and minimize voltage drop. Regular maintenance is essential for maintaining the performance of the electrical system. Inspect the wiring, connections, and lighting fixtures regularly. Replace any damaged or worn components. Regular maintenance can help prevent electrical problems and ensure the safe and reliable operation of the electrical system. Keep the lighting fixtures clean. Dust and dirt can accumulate on the lighting fixtures, reducing their light output. Cleaning the lighting fixtures regularly can improve their performance and energy efficiency. Finally, consider the aesthetic aspects of the lighting system. Choose lighting fixtures that are both functional and aesthetically pleasing. A well-designed lighting system can enhance the appearance of a space and improve the overall quality of life. And that concludes our discussion on voltage drop and shared neutrals in long lighting circuits. By understanding the principles involved and following the troubleshooting steps outlined, you can effectively address voltage drop issues and ensure the optimal performance of your electrical system.